Hey guys, this is going to be the 8th grade benchmark prep. For this video, we're going to go over some basic function stuff, how to tell if a situation is functional or not. We're also going to hit the real numbers and just some proportional situations. Primary thing for functions, what I need you guys to know, if x repeats, something is not going to be a function. So looking here, we've got a -12, -10, 0, 5, 8, and 15. None of those repeated, so this is going to be a function. Pretty much that's going to work the same way on all the tables, so I'm going to try to glance around for one that does happen to repeat. Actually, I'm not sure that I see any on there. That may be terrible. Each one may be a function. So I'm going to let you guys actually go through and figure. Actually, no, I do see one, but I don't see many. So if x repeats, not a function. That's what I need you guys to know on those. On this other section over here, I need you guys to remember that these are all xy values. X, y, x, y, and I can go through each one of those. But the first number is the x. What you're going to do is you're going to look to see if any of the x's repeat. So here we've got 10, -2, -6, 5, 8, -11. None of those repeated, so this is also going to be a function. So look for a set like on number 3. We've got a -13 here and a -13 here. Those repeat, and they have different y values back out. So this is going to be non-function. This section shouldn't take you hardly any time. Now, down here for the grass, this is where we do the vertical line test. If I can draw a line straight up and down and only hit one point, it is a function, because none of these, like, remember, this is the x-axis right here. If any of those x's repeat, it's not a function. So draw a line straight up and down. See here I hit 1 point. That one's good. Only 1 point there. But right here, I've got 2 dots on this x-axis. Let me do that in red. Because of just right there, that keeps this thing from being a function. So this is going to be non-function. And this front side ought to take you hardly any time. Alright, now for the back side. This is where you're going to go through, and you are going to label whether these are real, rational, irrational, integer, whole, natural, all of that. But here's what I will tell you on all of these. Just kind of glancing at it real quick. Yep. And because you guys are going to have this situation, every single one of these is going to be a real number. Every number that we deal with in my class is going to be real this year. If you want to know what a non-real number is, come ask me sometime. I will gladly show you. So just your quick reminder on this. Here's the chart that you guys can use. Natural numbers are the numbers that we are going to naturally count with. Like we don't start counting at 0. We start counting at 1, 2, 3, 4, whatever else. Whole numbers are the same thing, but they are including 0. So we have 0, 1, 2, 3, and so on. No negatives. Integers include wholes, so we still have 0, 1, 2, 3, but now we also have -1, -2, -3, -4, all of those, and so on. So integers are just like whole numbers, but we're including the negatives as well. No parts, no fractions, no nothing additional to it. For rational numbers, we are including everything on the inside, the natural, whole, and integers, but now we have parts. So we've got our fractions, we've got our percents, decimals, whatever else, but we still have 0, 1, 2, 3, -1, -2, and all of those. Irrational. Now it separates rational and irrational. If you have some kind of decimal where it's going on and on and on, and you can't tell me what decimal is coming next, that's definitely irrational. If I were to plug the square root of 2 into the calculator, I would get something crazy. It's like 1.3 and a whole bunch of other numbers. There's no way to tell what's coming next. Same thing with pi. 3.14, unless you have it memorized like some people do for some reason or another, it goes out infinitely. So there's no way without using a supercomputer to figure out what decimal number comes next. That's why these are going to be irrational. So going through these, I'm only going to do a couple of these for you guys, and then you'll be on your own for the rest of those. So 0.8, because it's got the part right there, this is what's going to be called a rational number. So to circle all the things that apply to it, it's going to be rational. You cannot be rational and irrational. You are either one or the other. But that's going to be all that applies to number 1, because it's not an integer, because it has parts to it, not a whole, not going to be natural or anything else. So now I'm going to skip to number 3, and the rest of those are going to be on your own. So 0 first shows up in our whole section. So we already know it's real, and we know it's going to be whole. It's not natural because we do not naturally count with 0. But if it's a whole number, looking at the chart over there on the side, if you need it, whole numbers are going to be integers, and they're going to be rational. Well, 0 is not going to be an irrational number, and again, you are either rational or you are irrational. You cannot be both. And the rest of those, I'm going to let you guys try those on your own. This section right here, I want you to go through and just label them A through H on the number line, figure out about where they belong. So I'm going to help you out with A and H, mostly because I don't have a calculator right here on there, and those are going to be easy enough. So this 0.75, I know that that is going to be clearly bigger than 0 and almost 1. So 0.775, it's not going to be exact, but it's going to be around here somewhere. So my 0.75, I'm going to label that point right there A. So I've done that one. That one's done. H, this is pi, which is 3.14. So I know it's going to be a little bit bigger than 3. So over here I would come to 3, put a little bit of a dot after it, and I'm going to call that point H. Now I'm done with H. My recommendation is to go through each one of these and write out what their value is as a decimal. That will help you put these things on the number line. Okay? If you got any questions on that, let me know and I'll help you out. This side is just setting up proportions. I don't think this is going to take you much time. I mostly want you to set up the ratios on this one. So number 1 says, Annalie reduced the size of a painting to a height of 1 inch. What is the new width if it was originally 16 inches wide and 8 inches tall? So I would recommend, I know it's been a while since you guys have seen these, but it's still good to know because, again, something like this shows up on the benchmark. I would do a WKU. W will stand for words, K stands for what you know, and U stands for our unknown, or what we're trying to find, really. So our words, we're comparing, let's see, let me change colors real quick. We're comparing width and how tall it is. So I'm going to do wide over tall. What we know about this is we know that it's 16 inches wide, and we know that it's 8 inches tall. And our unknown, we know the height. Well, height, I wish they hadn't changed from tall to height. I think what I'm going to do is I'm going to change this to an H, because that's really our height right there. We know it was originally 1 inch tall, and this is what we're solving for right here. Really, it just comes down to 16 divided by 8, which I'm willing to bet most of you guys already knew, making our x2. That's what we're looking for on that one. Going to be a very similar situation on the rest of these. If you have any questions, please let me know.